Hi everyone, welcome to part 2 of lecture 11, and in this part we will discover the Adam's law. So before starting the Adam's law, remember from the previous part we have discovered the total expectation theorem, and we say that A1, A2 until AN disjoint events, and we can calculate the unconditional events, unconditional expectation by using the conditional expectation, right? So the point here, the given one, the conditions are the disjoint events. So now let's consider that the conditions now another random variable. So in this case, again, we can calculate the expected value of x, the unconditional one, by using the conditional expectation. But the difference is the condition is just another random variable. They affect each other rather than an event. Okay. So if the y is discrete one, the condition conditioned random variable is discrete, we can use this formulation, which is the summation of the expected value of x given y is equal to some particular value times the corresponding probability of y. So, and that is the continuous one. Instead of the PMF, we will use the PDF. Everything else is same. And also, I can use these formulations to calculate the unconditional expected value of a random variables, or I can use more compact way, which is the expected value of x, which is equal to the expected value of x given y. So why we can use that one? So that is this part. This part can be considered as a new random variable, right? Because remember, the general way of calculation, the expected value of a random variable, which is like, let's say my random variable is a, so I can calculate the expected value of a with the corresponding probability, right? The summation of the random variable times the corresponding the probability. So consider that this is a new random variable, okay? And what is this? This is actually the conditional expected value of x, right? That is the conditional expected value of x. And also, I can just I can give a name to that new random variable, let's say, which is k, and the corresponding probability, this part. So I simply calculating the expected value of k, right? So what is the k? K is the conditional expected value of x. So that's why I can write the expected value of x, the unconditional y, the expected value of x given y. This part is the conditional expected value of x, right? And that is coming from that one. And actually, I am doing that. I'm calculating the expected value of a conditional expected value of x. So I can use this formulation. So that can be a little bit complicated for now, but I will give you an example to make things more clear. And remember that the inside term is the function of x, and this total guy is the function of y. So let's make it more clear. First let's look at the proof of the Adam's law. So what I want to calculate, or what I am claim that the total expected, the summation of the expected value of x given y times probability of y, which is equal to expected value of x, right? So what is this guy? We just seen in the previous lectures. This guy is actually the expected value of x given in some conditions, right? So simply, which is x time probability of x is equal to x given y is equal to y. Okay, so this guy, this part, which is equal to this one, and this part is the conditional expected value of x. And I know that that is the probability of y is equal to y. So again, remember from the previous lectures, we can write this guy, this part, as the probability of x is equal to x and y is equal to y, and scale up that form, that probability with conditioned event, which is the probability of y is equal to y. So these are, so the first, the summation, the index is x. So these guys will not be affected from the x, so they can cancel each other. And I will end it up with x times probability of x is equal to x and y is equal to y. This one, okay? Now I can change the order of the summations, and the things will be much more easier. So if I move that first summation to the inside, the index will be y, and the x is not based on y, so it's not depends on the y, so it can go outside the inner summation. So I can rewrite this part as the summation of x and the summation of probability of x is equal to x and y is equal to y, right? Okay, so what is this guy? In this part, I will go over, I will go through all possible y values, right? So, for example, for the y is equal to 1, I will check the x's. I will calculate the probability of the x's. For the y is equal to 2, I will calculate the probability of x's. And the summation of them will give me the probability of x, right? So for example, if I want to calculate the probability of x is equal to 1, I will keep this constant. Let's say the probability of x is equal to 1 and y is equal to y, right? Let's say which is summation of y. So I will check, I will change the y. Let's say y is 1, 2, and 3. And let's say x is equal to 1, x is equal to 2, and x is equal to 3. I will calculate the probabilities, right? So sorry, that's x is equal to 1. So that I will make it constant. And let's say the corresponding probability will be A, B, and C. The summation of them will give me the A plus B plus C will give me the probability of x is equal to 1. So that is actually the same as the probability of x is equal to x. Okay, so or simply that which is the PMF of x. So that's why I can write the probability of x is equal to x instead of this guy. So I will end up with the summation of x time probability of x is equal to x, so which is the PMF of x. So what is that? The summation of x times the PMF of x, which is the expected value of x. So that's why I proved that the summation of the conditional expected value of x, the condition is y is equal to y times probability of y, the PMF of y, is equal to the expected value of x. Okay, that is the proof. But if you don't feel comfortable, you can say skip the proof. But remember that there's equality. Okay. Still, that can be a little bit complicated, especially this part. And let's look at an example and make it more clear. Just revisit the minor example and let the discrete random variable y denote the number of doors selected. So remember the minor example. We need to choose one of the 3 doors, and if he choose the first door, the expected value of x will be 2 because it will he will spend 2 hours to escape from the mine. Okay. If he choose the second door, he will spend 3 hours to come, but he will come back to the mine. So remember how we can write this 3 plus expected value of x, 5 plus expected value of x in previous part. Now I can create these conditions, the expected value of x while y is equal to 1. So that's mean the conditional expected value of x, and the condition is choosing the first door in the first time, which is 2, right? And the expected value of x given y is equal to 2 is equal to 3 times expected value of x. So the condition is choosing the second door at the first time. And the similar thing for the last one. Okay. By using this one, I can create the PMF of this random variable. Now this can be considered as a new random variable. Okay. So the expected value of x given y can be 2, 3 plus expected value of x, and 5 plus expected value of x with the probability of 1 over 3, 1 over 3, 1 over 3 respectively. Okay, because they are the choosing any door has the same probability. They are equally likely. Okay, so even if that is an expected value of x here, the conditional one, you can think this one as a new random variable. You can give a name like k, m, l, x, y, etc. So that is a new random variable. We have possible values of that new random variable, and we have the corresponding probabilities. Okay. So ignore the name of that random variable now. How we can calculate the expected value of that random variable? It is easy, right? The value of that times the corresponding probability plus another value of them, another value of it times the corresponding probability plus another value of it times the corresponding probability. That will give me the expected value of this guy, right? And remember from here, the expected value of that new random variable, which is the conditional expected value of x, will give me the unconditional expected value of x. So, which is simply 2 times 1 over 3 and 3 plus expected value of x times 1 over 3 plus 5 plus expected value of x times 1 over 3 will give me the expected value of k, and k is equal to expected value of x given y. This guy, okay? And what is this? This is equal to expected value of x. And if you do some simple math, you will find that the expected value of x, the unconditional one, is equal to 10, okay? So please go over again and again to make things more clear, but actually it is easy to apply it, even if you don't understand the proof or the way of the follow. Just try to use them to comprehend what we did. Okay, so that is the Adam's law, and for the summary, we can use the Adam's law to calculate the unconditional expected value of x by using the conditional value of x, and the conditioned event, conditioned one or conditioned situation is a random variable instead of an event. Okay, which is the differences from the previous part. We covered the total expectation theorem. Okay, so that is the end of part 2, and we will continue to part 3.